and flee from the terror of Lord Restod. What I'd like to look at is one last graphing problem. So this is one last graphing problem from the Unit 2 work that I think a lot of people struggle with. So once again, this is a graphing problem. Yay, everybody's favorite. And specifically, this is the E4 problem. This is an area under a curve. Okay. Now, if I, once again, just kind of create, ooh, look at this. Create a quick graph. Ding. I can't drag that, make it bigger. Oh, that's weak. I probably want to, it just won't let me. Okay. Ting. Okay. This is our time axis. Our second axis here is velocity, which makes things a little different. Okay. Drawing a shape. Oh, I guess I could have just drawn a graph like that. Whatever. I'll just draw the shape by hand. It's fine doing that. Let's just go with 1 second, 2, 3, 4, 5. So this is 5 out here, 2, 3, 4, 5. Okay. In this problem, you're given a velocity time graph, and it has some shape to it, probably a little bit different than this, and you're asked to find both the distance of how far something has gone and the displacement as something has gone. Remember, displacement has this vector symbol above its head. Let's also just mark this 1, 2, and then let's mark this as 1, 2, 3 negatives. Okay. In order to find the distance, it is just the total area, and all of the area is a positive number. Okay, all the areas are positive here. So what we're looking at here is I'm trying to find the area under the curve, and this curve here is the line. It is the function we're looking at. Okay, so I'm looking for all of this great area sitting in here. Now, I always, when I do this, if I'm doing this for a time of 0 to 5 seconds, I'm going from this beginning point to this end point out here, okay? And that means 5 seconds and 0 seconds are kind of my walls. Now, my other walls here are always the line itself, because I do a terrible job tracing, the line itself, and my x-axis, my time axis. So we can see by doing that, that's how I got this green region right here. That's why all of this is green. And if I look at this here, the line to the x-axis, I can see I'm forming a triangle. Woo! There it is. Whoop! There it is. Give me a whoop, there it is, chat. Okay. I didn't get a whoop, there it is from chat. Who knows? Who knows who's in chat? Okay, so those are my areas. In the case of displacement, they are not all positive. In a case of displacement, some positive, possibly some negative area. Okay, so let's just do this. Let's just find the area first, okay? Looking at this weird trapezoid shape, nobody would ever cut a sandwich like that, but we can do a few things to figure out what this area is. One, we can kind of see that this triangle at the edge here, it actually looks very similar to the triangle that's missing right here, and it is. It's actually symmetric. And if I were to cut this out and place it here, I have a rectangle which is 2 up by 3 across, and 2 by 3 is 6. So we kind of know it like that. If we didn't want to do that, or we didn't see it, I recognize I got two triangles and then this larger rectangle. Now, if I solve the area of a triangle, remember, that is just half of our sandwich, 1/2 base times height, or, depending on who you are, length times width, it doesn't matter. And for this triangle here, it's got a length of 1, a height of 2. 1 times 2 is 2, and then half of 2 is just an area of 1. So this is an area of 1 on the inside, okay? For this going across, it's got a width of 2 for a rectangle, and an area of a rectangle or a square, if you all remember, is just a length times a width, or a base times a height, however you think about it. It's got going across a width or a length of 2, because going from 1 to 3, 1, 2, and then going up, it's 2 as well. 2 times 2 gives me an area of 4 on the inside. And then if we do the same thing applied over here as we did this initial triangle, this side's a 1, going up is 2. 1 times 2 is 2. Half of 2 is indeed 1. Okay? So this whole segment up here is 4 plus 1 plus 1. That gives us an area up top of 6. Okay? If I look over here for this area, do the same thing with the triangle, 1/2 base times height. I see I'm going from 4 to 5 seconds, so that's a base of 1. I see I'm going from 0 to -3 meters per second. So this gives me a height here of, technically speaking, -3. What I like to do is I like to ignore that negative. I like to declare eventually this area will be negative because it's below the axis. But I like to make that note later on. If we want to find that area, though, 1 times 3 is 3. Half of 3 is an area of 1.5. Okay? So our total area here, if all of these numbers are positive, 6 plus 1.5, 7.5. Units of whatever the distance of velocity is, more than likely, it's in meters. Okay? For the displacement, this distance, or this displacement traveled up here is a positive because all of these velocities are positive velocities. So what we did here is we took to get an area, we took a velocity multiplied by a time because we went up some amount and then over some amount for that area, and that was a displacement. Since these velocities are positive, this displacement is positive, so that gives us a positive 6. Over here, like I mentioned just a second ago, this is technically a negative value because it's a negative velocity, which means this is a negative 1.5 meters of displacement, okay? So if we look at this, we're really going to have a positive 6 plus negative 1.5. That gives us 4.5 meters. And we're done. We could walk away. That's the end of that game. Fin. So any questions regarding this real quick? Got about 2 minutes here before I jump off for the AP class.